In this tutorial, we will be making this Angry Birds-like game. All you need is to set up Godot. All the assets for this project, plus its source code, will be linked in the description. Alright, so you should have set up a basic Godot project. If you don't know how to do that, then just Google. We're going to press 2D scene, and we're going to name it something like game. Drag in the assets you will need for this video. You will find them in the description and just drag them over. You'll see we have some bird assets and everything. But as you can see, it's blurry, and this is not what we want for pixel art. So we just go in project settings, search texture, click on the rendering textures, and change this from linear to nearest, which will make our pixel art look crisp, like pixel art should look. Let's just press Ctrl S and save our scene, and then run it. Select current. And there we go, we have an empty scene. Let's start with the bird. First of all, add a rigid body. Name it to bird. And add a collision shape 2D. We're going to give this collision shape a sphere collider, because our bird is a sphere. So what we want to do is we just want to take this bird and child it under the bird rigid body. Then we want to center it. So we change its position to 0, 0. And just change the collision shape. There. So now if you press play, you should see the bird falling down. Let's quickly center our bird. We could do this by moving it, but since the bird is on 0, 0, it's better to just add a camera. And now we press play and we see it's in the center of our screen. The bird currently just falls off the screen. So let's add a floor for it to collide with. First of all, static body 2D. Floor. And now we give the static body a collision shape. Give it a rectangle collision shape. And just move the static body itself, not the collision shape. Because as you can see, if I now move the static body, the collision shape is not at the center. So I'm going to move the static body back to 0, 0. Just move the static body itself to something like here. And then the collision shape, we can just change it to fit our entire scene. Boom. Yeah, now it will collide with the floor. Next, let's add some terrain using a tile map. Just to add tile map layer, not tile map. If you don't see tile map layer, you have an old version of Godot, or you have a new version of Godot, and the tutorial is 5 years old. Tile map layer, let's call this something like ground. Near the right, we see tile set. We click on it, click new tile set. Tile set, let's click down here and change our tile size to 32 by 32 because that is what I chose. Drag this over here, click no. Okay, so as you can see, we have all our grass tiles. We wanted to auto tile. So to set up the auto tile, what we are going to do is, first of all, you can see that it's off center. So we're going to change this texture region to 42 by 42. 42. And basically, the tile itself is 32 by 32, but the texture can be bigger than 32 by 32. So if I paint it, you see the texture is stretching out. You might be thinking, why is the texture region 42 by 42, but the tile size is 32 by 32? This is because the texture actually stretches outside of the tile to make more fluffy grass. You see it's stretching outside of this orange line. And this also just allows us to tile it better. Okay, to tile it better. Now let's just click on all of these in setup. Then we set up a new terrain set. Terrain set we use for auto tiling. The mode is match sides. We add an element, call this grass, and give it an appropriate color, like green. Then on the properties, we select a property, terrain set 0, grass. And basically, what we do is we just set up the tile map. So we click in the middle. And basically how auto tiling works is if we click in the middle, we say we have to exist and a neighbor above us has to exist. And then for this one, we say we have to exist and a neighbor below us has to exist. So if I paint it, it's going to do this tile. And as you can see, only it exists. So it's going to choose this texture. But if we put another tile above, it's going to look like this. Because as you can see now, it exists and there's a tile above it for the bottom one. And it exists and there's a tile below it for the top one. So we're just going to quickly set up this for all of them. This one is like this. Okay, so this is how the tile set looks. Just quickly set it up yourselves. Okay, so if this all works correctly, we should be able to paint some ground. So what I'm going to do is I'm just going to zoom out and maybe paint some ground like this. Something like that. Now, if you play the game, we see some ground. But the game is a little bit too zoomed out for me. So let's just zoom it in by going to Window. And just taking this and multiplying it by 0.75. Making it a bit smaller. So now, see? Now we see our purple box is a bit smaller. So let's also adjust our ground to be here. And then just move our floor up. Now if you press play, our bed falls and we see the ground. But we want the bed to actually collide with the ground. So here on the ground, let's just check physics layer, add element. Now under tile set, paint, physics layer. Now we just see we have a full box. So let's just click on all of these that have a full box texture. Then let's click on this one now and just right click. If you're on this edit points tool, you can right click to remove. Now we click on it again and we see this. So you click on this one, we left click this time and just move it over. Click like this. Like this one, left click, move, click. This one, left click, move. And then let's just toggle grid snap, half pixel snap, so that we can refine this just to be better. Okay, now click. Now we just click here and we can just click rotate left. This one, rotate left again, and this one, rotate left again. Oopsie. There. Then this last slope. Just go like this. Click it. And then this one. We just add a point here at the bottom, at the side, and at the top. And if we are in this yellow, this blue mode, we can just hover over one of these sides and we see a plus and we just left click and we can move it over. Boom. There. Click. We just set up the physics. So if you press play, the bed should collide with the terrain. So now with this old floor static body, we can completely delete. since the bird is no longer colliding with that. Okay. Now, our scene is almost set up. Let's quickly set up some background. I just the preferred method, just adding a sprite 2D and giving the sprite a gradient texture 2D, not a 1D, a 2D. Then what we can do is just take this dot and move it down and change this gradient to be something like this shade of blue, and this side to some other shade of blue, and you can just play around with this colors. So now we have a nice gradient. We can just scale this up and see, get this nice sky gradient now. And basically we're just generating a 2D gradient texture and we're choosing some colors. The only problem is it's in front of everything. So let's go on the ordering, change the Z index to -10 or something. Now if we press play, we see we got our sky color. Okay. But there's one problem with this, and that is if we zoom in, you might notice some blocky colors. This isn't that noticeable, but if I change it to something like black, you can see the blocky colors. This is because our texture resolution is only 64 by 64. And we are changing the scale, but we're not changing the resolution. So instead, let's reset the scale back to 1 and instead change the resolution of the image instead of changing the scale of the image. There. And now we have a high quality background texture that doesn't look blocky. Okay. Now we got our bird and our background and our terrain and everything. What we're missing is obviously our slingshot. So let's just drag it in and move it around. The way I move it around is by pressing W and then just clicking and moving it around. And what W does is it selects this tool, W. Slingshot, we got our bird, we got our terrain. But before I go further, let me try full screening this. And we see, okay, it's not full screening correctly. So up here, just click this. And we see we have a problem. Is our camera is growing its range and we're seeing outside of our scene because of our viewport being scaled or window being scaled. So the way we fix this is just by going project settings and searching window, and under window, our stretch we set to viewport, which will mean it's gonna keep the viewport size instead of zooming the camera out. But the only problem is, again, we see some black bars at the sides because Godot is trying to keep the aspect ratio the same, and thus it creates black bars on the side to ensure that the aspect ratio is always consistent. And we don't always want these black bars because most phones are a bit wider, maybe a bit thinner, most computers also. So under this viewport mode, we also have aspect, which is currently on keep, but we can change it to keep height to the top, and I press play. We see the slingshot is at the top, and I can do this, and the slingshot stays at the top, and the screen just gets wider. And you might see, okay, but we're stretching outside of the bounds, and this is not a problem because most devices are going to be this wide if you're making something like a mobile game. So all we can do is just be preventative and say, okay, this ground is a bit further over and this background is maybe a bit wider. So that way, even some really wide devices can still work, and we have no black boxes. Okay, so let's start the actual coding. The first step is actually picking up the bird. So let's give the bird a script by pressing this button, clicking create. Now we have a script. And all we want to do is we want to check if we are clicking on it and then moving our mouse, and then we move the bird to our mouse. So it's basically pick up and place. So what we can do is we can click on this, and in Inspector right next to it is Node. We see all of these signals. These are things that gets called once a certain event happens. The event we're looking for is right here, mouse entered. Basically, this tells us that the mouse has entered this collision shape of the bird. So we just double click it and click on our bird with our script. We see it sets it up for us. Let's quickly test, print, test. And let me just move it over, and nothing is happening. Nothing is printing out in this console. So what we have to do is we have to go under input and make it pickable. This just allows the mouse to be detected. As you can see, once we put the mouse on the bird, it prints test. Okay. Now we have mouse entered, but let's also connect mouse exited. Exit. Let's print exit. Let's change this to enter. And now we can see enter, exit, enter, exit. So we detect if our mouse is on our bird, but now we have to detect if we click down with our mouse. The way we do that is by going to product settings, input map. And this allows us to define some inputs. So let's define a new input called drag and place plus. And this edit here is listening for input. So hover your mouse over it, left click, press OK. So now we see we have one input for drag, which is left mouse. So what we can do, go func underscore. This is autocomplete, so just press down arrow. And we can see input. Just press enter to autocomplete. And now what we can do is check if input dot is action just pressed drag. And if this is, we just print pressed. So now we have three things. We detect when the mouse enters the bird, exits the bird, and when we click. See, it goes press whenever we press. Okay. So now we have to do is just combine this. When the mouse has entered and we're pressing, then we pick it up. So the way we do this is by just creating a boolean mouse on bird who is false. And when the mouse enters, we make this true. This mouse exits. When the mouse exits, we make this false. So now we check, instead of checking is input or is action just pressed, we also check and mouse on bird is true. So now we're checking if we clicked and the mouse is on the bird. And let's see. We can do everything and nothing happens, except if we put our mouse on the bird and click. Now what we can do is create another boolean for bird held or something. Go to false. And when we press on the bird, we say bird held is equal to true. And now we check if bird held, then position is equal to get global mouse position. So basically, this position is the position of the node that the script is part of, which is the bird. And so when we say position, what we're modifying is this position here. And if we hover over it, we can see the property name is position with no caps. And this is true for all of this. So if I hover over, let's say, the property mass, you can see its name is mass, no caps. So if I ever want to change the mass, I just do mass equals to 5. And even this, I can do input underscore pickable is true or false. So all the properties you see here, you can edit by just hovering over it and seeing its name, and then just going name equals to something. Okay. So let's test it. Also, and just get global mouse position, just gets the position of the mouse. Now let's check. We can pick it up and we can't let go. Great. So let's actually also let go. So we do the exact same as this. So all we do is we just check if input, this time dot is action released, drag, and the bird is being held, then the bird is held is equal to, set equal to false. So if we release and the bird is being held, then the bird is stopped being held. Let me just also change this to true. So if the action is released and the bird is held, then the bird is no longer held. Let's see. Pick up, drop, pick, and it breaks. Okay, so the point is that it is broken, and the way we fix it is by not fixing it. This is the best tutorial you ever seen in your life. No questions asked. What we want to do is when we release, let's just add a. Let's just change the linear velocity to vector to 200, 200. There. So basically, we just pick it up. Oh my word. 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 Oh my. Okay, so the problem is that let's freeze it actually. And when it's frozen, you can just move it around and about. Godot doesn't do any of its physics things. So if I let go, let's unfreeze it. Like this. So now we can just pick it up, let go, and it drops. But we can't pick it up again. Okay, so this problem doesn't really matter that it only works once, because just the fact that we can only pick it up once isn't going to affect us, and we don't know what the problem is, but it doesn't matter, because in game development, you don't care, you just fix it. And if it's not a problem, you don't fix it. Okay, so we have our bed, but we want it to basically get pulled back and then stop at a certain point. So let's just quickly move it in the center of our slingshot. And let's imagine our slingshot has some sort of radius. Don't do this. Don't add this collision shape yourself. I'm explaining. Stupid. We just give it some sort of radius. And we imagine that we just pull it back and it's on our mouse and it's on our mouse. And when we pull it too far back, it's no longer on our mouse. It's on the edge of this invisible radius. What we can do is just add a marker 2D, and what we want to do is just mark the center of our slingshot. Maybe here. In our bed, we just get, let's just call it like sling point. Our bed, let's do add export sling point. And let's set it equal to null. Let's also find a type, so double points marker to D. Boom, chicka pow. And also put var here. Export var, boom, boom, boom. Yeah. And now on our bed, we see we have a sling point. We can just assign, click on our sling point. Now we have a point that acts as the center of our imaginary crossbow slingshot. And why is this useful? Because now in the ready function, which is basically like the start function, we just get var start point, set it equal to start point. Let's define it as a vector 2. Start point is equal to sling point dot position. So it's basically going to be the same as this point's position. And we're also going to set our bed's position. So set our bed's position. So position is equal to start point. So now, whenever we play, our bed is going to be at this marker. And it's going to be its starting point. And we're just going to put it here. And this might feel redundant, but there's a reason why we do this. I'm not going to tell you why. Just figure out. Start point. And now, what we want to do is we set our position to our global mouse, but we want to check if our start position dot distance to our current position is bigger than, say, 500, then we, as we discussed, we put it on the edge of our imaginary radius. Else, we just set it to the mouse position. So I typed direction, I meant distance. So if this point, distance to our bed, is bigger than a certain amount, we want to do some code. For now, let's just test it. We can drag it back a lot. And now it's just, we can't drag it past a certain point. And let's decrease this radius to 50. Now let's see, we can drag it back. Let's maybe make it 85. Now we can just drag it back, let go. Now, another problem is that we can move it around inside the radius, but as soon as it hits the outside of the radius, it just sticks there. So what we can do to fix this is obviously this code. So if we're inside the sphere, set it to our mouse position. If we're outside the sphere, set it on a point. I'm going to pull out paint for this. If this is our center, this is our bed, you basically want to move our radius, which is 85, to our bed, and this is the point on the circle. So if our bed is inside the radius, put it on our mouse, and if our mouse is outside the radius, put it on this point on the circle. And this is actually easy math. Easy math. Yeah, easy math. Just var difference now var direction is equal to start point minus position. Boom, boom, boom. Boom dot normalize. And let's change this radius. We can just make it a constant because So I'm just replacing this 85 with this constant. And the reason why is so that we can just change it quickly. But basically, var direction or offset is equal to direction dot multiplied by radius. Now we just go position is equal to start point plus offset. And that is the maths. Who could have, oh my word. Put the position on the left minus the starting point. I've switched it around. Okay, and that is the, oh my soul. Hello? Direction. Position. Yep, obviously. Replace this position with get level mouse position and this one too. There. And boom, I just fixed the math. Understand how it works. I'm going to quickly tell you. But if you don't know how it works, you're probably not going to stand with by my explanation. So boom. What we're doing is we're getting the difference. So we're taking our mouse and subtracting it to our starting position. So we're getting the difference between here and here. Then we're normalizing it, which is basically making its length 1. Then, as you can see, we normalize it. Then we multiply it by the radius, which makes it length, the radius length. And then we got the point. Then we add it back to the start position. Boom, boom, boom. You didn't get any of that because you're following a tutorial about Angry Birds. Look, it works. Just copy it. Now we want to shoot the bird forward. Now, luckily in this code, this is when we want to shoot. So all we want to do is just give the bird a velocity in the direction of the point, and it's going to do the parabola thingy. And the way we do this is just by going linear velocity, and it's equal to, and all we actually have to do is just go position minus starting point and negate it. So there, minus position minus starting point, and oh, multiplied by like 100. There we go. It's flying. Phew. Let's do something fun. We see our bed, and what I included is, you can see we have obviously our bed angry, which is you can use if you want, but we have a weird looking bed, and then we have a weird looking mushroom, and I think you'll be able to notice what we're doing. So we can just drag this onto our bed sprite, which is under our rigid body, and also this mushroom, we do the same thing, and we set its position to 0, its position to 0. Now our bed is white. Let's rename it to body, and this one to belly. And what you can do now is just, let me just hide this collision shape. This is fun. This is fun. Convince yourself it's fun. Click on body, click on visibility, and modulate. Now you can see we can choose a color for our bed. That's great. Let's choose penguin. Let's choose the tracing. Let's choose yellow, orange. Yeah. orange. There. And you can also take your belly, visibility, modulate, and give it like a nice belly color. And now you can customize your bird. Wow. Great. Let's actually add some crates for our bird to hit. This is easy. We just do rigid body again. Rename this to crate. Give it a collision shape. Change this collision shape. So to a rectangle. Drag in this crate. Hold it under the rigid body. Change this transform to 0, 0. So it's on the center of our parent. And change this hitbox to this. And then move it down. And then press Ctrl D. And then move it around. And press Ctrl D. And move it around. And boom. And boom. And wow, you got some boxes. Let's see. Oh, we can hit it. But our boxes are too heavy. So what we can do is just click on this box and make it its mass 0.5 and all of the other boxes too. This is fun. 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 Okay. See, all of our boxes are half the weight and our bed is double the weight. Interesting. The boxes are half the weight, the bed is double the weight. Okay, anyways. So we got some boxes. Let's add a piggy, but instead of adding a piggy, because that would be too close to the original, I added this little animal called a fennec fox, and I thought, oh, this looks cute enough to be shot at with a bird. So, boom, fennec fox. Shoot at it. It's not cute, just shoot at it. Shoot at it. Just shoot at it. Okay. Since we're lazy here, we duplicate this crate, move it up, and see the sprite. Just drag our PNG onto the sprite, and now it's a fox, and it's all great, and boom, we're lazy. But the problem is it's still a square hitbox. So let's change this to a circle hitbox. And boom, yeah, that, done. See, we can shoot it, and it's rolling, and there, Angry Birds done. But before we finish, we probably actually want to destroy this enemies. Let's just rename it to a fennec fox, spelled correctly, and the sprite 2. And we want this fox to kill itself when we hit it. There's no other way to put it than that. And the way we do this is by giving it its own script. So what we're going to do is just check for an impact. And if the impact is large enough, the fennec fox will kill itself. Actually, wait, this is this is YouTube. The fennec fox will hide itself forever. Yeah. Okay. So we check. First of all, we check if it's actually colliding. So if get colliding bodies dot is empty. We want to check not. So if the colliding bodies are not empty, then we go through all of our colliding bodies and we get the body's velocity. Now, the body can be two things right now. It could be our box, which is a rigid body, our bed, which is also a rigid body. Both of these are rigid bodies, and our floor, which is a static body. So basically, we want to check if the thing that we're colliding with is a rigid body, then the body velocity is equal to I dot linear velocity. But if it's not a rigid body, then the body velocity is vector to 0, 0. It's nothing because it's either a rigid body or it's the floor, and the floor doesn't move. So basically, we just got the velocity of the body that our fox is colliding with. So what we're going to do is check the velocity difference, and is equal to the linear velocity minus the body velocity. And basically what we're checking is the velocity difference between our fox and our thing that we're colliding with. So let's say the fox is moving right at 10 per second, 10 units, and our box is 2. They're both moving right at 10 units per second. If mid-air the fox collides, it won't destroy itself because the difference between its velocity and the box's velocity is 0. Thus, the impact is 0. But let's say the box is moving left at 10 units, the box is moving right at 10 units. They will collide at a difference of 20 units a second. And the fox will unalive itself. So basically, we just check if the difference, not length, is bigger than the depth. Oh. Unalive impact, then Q3, which basically just means the node will destroy itself. Let's define the unalive impact. Constant unalive impact equal to 120. Boom. And nothing happens. Let's try to hit it. It doesn't destroy itself. Let's try to hit it better. And it still doesn't destroy itself because we see 300 errors are busy erroring themselves. And this is because it says contact monitoring is null. And what this means is our Fennec Fox rigid body isn't allowed to monitor contacts. Just click Solver, contact monitoring enabled, and max contacts free. So basically what this does is say the rigid body can tell us when it hits something. So if 3 boxes are touching us and a 4th one touches us, we don't detect the 4th one. Wow. It unalives itself. Wow. Oh. Hey. Okay. So we got 2 problems. Let's say I miss. Now our bed is just... Oh my... What? You can shoot it and our bed is just stuck here and it's not going to reset and allow us to shoot again. What we want to do is just check if the bed is standing still or moving too slow for an amount of time. It unalives itself. So basically, we just check every frame if our linear velocity length is smaller than 10 or something. So if the speed that we are moving is smaller than 10, we will start a timer. So I'm just going to create a timer variable. So equal to 0. We start ticking a timer. Timer is equal to timer plus delta. And what this is doing is every single frame, it increases the timer by the time since the last frame, which means the timer works like a timer. Let's see. We can see, okay, it's counting up 2, 3, 4, 5. Every single frame is just increasing by the amount that the previous frame was the time that the frame held. You got it. You got it, dude. And then we check if the timer is bigger than 2, destroy. And now we press play and we can shoot and boom and destroy. The only problem is if we do nothing, it also destroys itself. So we need another bird called bird shot, something like that, which is basically going to tell us that the bird is already shot. When we shoot it, we just set bird shot to true. And also we can fix a lot of problems by doing if bird shot is true, return. And basically this tells us if the bird is already shot, return basically means stop here, don't execute the rest of this function. So now we have a bird that we can shoot and we can pick it up again and it will stop. And just one last thing. We should only increase the timer if the bird is already shot. So now the timer won't increase, but if you shoot it, it stops eventually, and it stops eventually, and it stops eventually, and it stops. Timer will count for 2 seconds and it will destroy itself. Now we need it to reset. And the way it resets, when we destroy itself, it's going to create a new bird, and that new bird will do exactly the same as our current bird. So let's do new bird equal to load. And basically what we're going to do is we're going to turn this bird into a scene by just dragging it here and saving it. Now we got this bird scene, which is basically like a preset that we can load. So basically we're destroying the current bird and we're loading a new bird. Once we loaded the bird, we have to instantiate it. And now our bird is actually created. We load it, we create it. And now let's add it to our scene tree up here. Now the scene tree, if you haven't noticed, works like a family tree. This one has a parent, which is this one, which has a parent, which is this one. And this one has children, which are all of these. And this one has a sibling. You understand how the scene tree acts almost like a family tree. So what we want to do is this bird, this new bird, we want to add it to the scene tree. And the way we do that is using add child new bird. Now, what add child does is it adds the new bird as a child of this script. So since the script is on the bird is literally going to duplicate itself and child it to itself. But we don't want that because the bird is also currently being destroyed, so it will destroy all of its children. So what we want to do is we want to create a new bird and child it to the game scene, not the bird itself. The way we do that is just by going get parent dot add child. So basically This bird is getting its parent and giving it a child, which is another bird scene. And we test this and it breaks. If I click here, I can assign it to something. But if I create a new scene, it's not assigned to anything because it doesn't even know that the marker exists. So we're just going to let the bird give its child a sling point. So when we create the child, we go child.sling point is equal to our sling point. So now we're just gonna propagate this reference all the way through the children and boom, boom, boom. That's you see, it works. We shoot it. It rolls. It stops. It teleports, and it does that all day long. First of all, our slingshot, we want our bed to be in between the slingshot. So what we're going to do is just bring it back one. And then I have this nice asset for you called slingshot front. We just show this to slingshot, reset its position, and change its ordering to 1. And now we can see our bed is in between our slingshot. Now let's add some sling lines as well. Little lines between the bird and our slingshot. So let's just add a line 2D. We'll call this left line, left line. Duplicate it, Control D, and right line. Basically, we just click here. We just, under points, we add a point. We move it here, and on the plus mode, we just click for a right line. We also just click and move this about. So now we have 2 lines, and what we want to do is just have our bed and have these lines go from here to here, and this line go from here to here, and it's gonna look great. So let's decrease the size maybe to 8. No, 6. No, oh yeah, 6. And this one, I'm just gonna make it appear behind, and this one I want it to appear in front of the bed, but behind of the slingshot front. So slingshot front, we change it to 2. So we have lines now. Let's give them a more appropriate color. The specific color that you can give them is 5E5931. So just here at the bottom, 59, I forgot. 5E5, type that in, and now we have this turquoise looking color. Let's select 5E5931 again. We want the slingshot to have a reference to our bed and set these, basically set this point to always be here and this point to always be here, where no matter where the bed is. So what you can do this is let the bed notify the slingshot of its existence. Because the bed, we're creating a new bed every time, and every new bed has to notify the slingshot of its existence. So we give the bed a reference to our slingshot. We're just going to make it a node today. So now we can assign this to slingshot. And basically, we just want to maybe call something like, basically, we just want the slingshot to have its own script and a func target, a variable called target, and then every frame, which is a node to the, is going to be our bed, which is a rigid body 2D. In every single frame, we're going to go line point 1 is equal to the bed and line. Left line point 1 is equal to the bed, and the right line point 1 is also equal to the bed position. First of all, we need references to left and right line. So just click on empty space to unselect, then hold Control, drag left line, click on an empty space, hold Control, drag right line. And now we have references to left line and right line. All you have to do is check if target is not, if target is not null, if the target is actually set, then left line dot set point position, point number 1 to target dot position. And we do the same thing with right line. So we are setting the point position of point number 1, and everything should work, except we haven't defined a target yet. We have this target variable, but it's currently just defaulted to null. So we want the bed on ready. Basically, take slingshot dot target and set it equal to self. So the bed is basically gonna set this target of the slingshot to itself. Now we see it's moving, but it's not correct. Basically, convert the target's position to the coordinate space of the line. And basically, we just do this by going left line dot to local target position and right line dot to local target position. And now we have our thingy set up and it's all nice. The only problem is that it is smack bang in the eye of the bed, and that is because we're only setting the point to the position of the bed, and the position of the bed is right in its center. So let's just take these points and offset them by an amount. So 30, 0, and this one offset it by negative 30, 0. So the one line goes to the left and the other one goes to the right. I flipped it around. So let's do negative 30 and positive 30 instead. Boom. Now we got this, but it's still too much to the right. So let's add more of 20 to the left and right. See, and that's great. That's amazing. Now, the other problem is that even if we let go, it still sticks to the bed all the way. So we just want the bed when we let go to tell the slingshot that its target is null again. So the slingshot will forget that it ever had a target. And we see it's no longer following the bed, but it's kind of stuck in limbo. So in the slingshot, every single frame, if the target, and let me just change this. So if the target is null, hide, else, show. So if the target is null, hide, else, show, and do this. So now it's hidden when the target is no. And we accidentally hid the entire slingshot. What I meant to say is to left line dot hide and right line dot hide. So we only want to hide the lines. When the target is no, hide the lines. When it's not no, show the lines. Mad respect tutorial maker. We see we still have a problem, and that is when our bed is in limbo, when our bed is destroyed and a new bed is created, it doesn't have a reference to our slingshot. And it's the same issue as the marker one that we solved previously. We just want to tell our new bed that slingshot is equal to slingshot. So now our new bed will be aware of the slingshot reference and tell the slingshot to be like, "Ooh, I'm attached to you. Ooh." Okay, now two problems. When we shoot the bed to the left, it's never going to return. And that is because if I zoom out the camera, you can see that the bed is just never going to stand still because it just falls into the void forever. So what we do is in the bed under the process, we just check if position dot y is bigger than 400 Q3 and do all of this. So it's going to do the exact same as if the timer ran out. Now the problem is we're doing the same thing twice. And in coding, this is called bad. So we create a new function called kill. And basically this function will be able to be called and it will execute the code of the function. So if we call this, it will execute all of this code. You see, now if we shoot it in the void, it will create a new one, create a new bed to take its place. Let's add some polish. And this polish is actually really quick. Duplicate the ground, call this background, and just completely like, no, click on background and just remove everything of background. And imagine that it's like kind of a background in the distance. We just add some mountains and all going like this. This is just some mountains. And basically, if we run the game, we see, oh, we messed some things up. So let's move this back. So now we got this nice scene with the mountains in the background. Ooh, there's some ugly mountains. Now, if we run, we see something. We see these tiles aren't tiling correctly. Let me just zoom in and we see this grass goes here, but it doesn't go down here. And this is because some tiles render below other tiles. So if we look at this grass tile here, tile grass tile here, we see it has some overhang here, but we don't see the overhang here. And that is because this dirt block is rendering above it. And now it's not tiling nicely. So what we do is we just z-index of 1, everything that's grass. And now all of the grass nodes will display above all of the dirt nodes and make the tiling work and make the tiling work. And we see it tiles nicely now. So now we can play it and we have some nice terrain with a background. Now, obviously this background is not behaving correctly. First of all, we have to disable its collision and bring it back one more. Now we have this nice background and this nice foreground, but I kind of want this background to blur a bit. And the best way to do this would be to just make it a bit invisible. Now we press play and we got this blurred background and it's all great, except if you look really closely, you'll see that wherever the pixels are doubled up, the transparency is almost adding onto each other, and that's a no-no. And we're going to fix that quickly by doing the naive solution, duplicating this background, this sky, childing it to our background, bringing it enough forward to display above, changing its visibility to this. And basically what we're doing is instead of making the background invisible, we're adding this invisible almost sky between the background and the foreground, adding this mist. Boom. You see we have got this nice scene. Okay, so we have our mist, but it still doesn't look correct. So I'm gonna click on the background again and not changing its transparency, just darkening it a bit. So I'm gonna go to HSV, and this V we're gonna move down to maybe something like 63, 64. Okay. So now the background is darkened and it blue, and now it actually looks like a background. And we've added all of our gameplay. All we have to add now is a level loading system to have more than one level. So what we want to do is, firstly, instead of the crate being a separate scene, we want it to be the same scene. So let's delete crates 2 to 5 and then crate 1. We drag it and we create a scene. Same with the fox, drag it, create a scene. Now is really easy to just drag in some crates. And let's say we want to modify all the crates to be slightly heavier, 0.6. This means all of these crates now have 0.6 here because they're all inheriting from the same scene. So let's just change this back to maybe 0.5 and just do the level again, but this time with the scenes set up. So we know that it is a scene because of his icon here. Just duplicate it, move it around. Yeah. All of these, we chart it to level, then level, create a scene of level 1. Oh, I forgot, crate 5 is not on the level. Let's try again. Level, save. So now if we delete level 1, we can just drag it, and delete it, and drag it, and delete it. Now let's quickly create a second level. Let's create a node, call it level underscore 2. And also keep in mind the naming is very important. I'm doing a level underscore 1, level underscore 2. They're all following a pattern. It's level underscore number. And the reason we do that is to basically automatically find the next level. I'll explain it later, but just do this naming convention. of doing level underscore 1, 2, 3, all the way down to whatever. So we have a second level, drag it, save it, and now delete it. So now we can drag our second level, we can drag our first level, and we have 2 levels. But obviously we want to load it with code. So under our game, let's give the game a script. And this is basically, let's create a function called load level. This function is going to take in a, let's say a level number, which is an integer. And what we want to do is just the same thing we did when we created a new bed, is just created a new bed, is just or new level. We're going to load the level dot instantiate. So we load it. Oh my word. Instantiate. We load it. We instantiate it. And then we add it to the scene. So add child, new level. And since the script is on the game scene, we will add child as a child of the game scene. Okay. So let's quickly test it on ready, which is this basically on the start of the game. Load level 1. And we can press play and it's going to load the level. And if we do load level 2, it's going to still load level 1. This is because we're passing this level number, but we're not doing anything with it. So basically, as you can see, we're loading this level. And all we have to do is take level number and basically squish it in here. So let's say level number is 1. Then we're going to load level 1. If level number is 2, we're going to load level 2. And the way we do this is just by having 2 separate, like this. So we have 2 separate strings, parentheses, which are added together. So it's just going to do this string plus this string. And in between these 2 strings, we're going to add level number. The only problem is that it doesn't want us to add a string with a number. So let's convert this number to a string. So basically, this level number is currently a number, but we want to convert it to a text number. Basically, we wanted to convert it to the text equivalent of a number using string. So basically, we're adding this string to this number and adding dot scene. So now, if we do load level 1, we see it loads level 1. If we do load level 2, see it's going to load level 2. Now, we can load levels, but we want the levels to basically automatically change. And the way we do this is by clicking on this level and creating a script, and let's call it just level, okay? Because we want to add the script to all of the other levels. So I'm going to add the script to level 2 and level 1. And if you create more levels like level 3, add the script to the level node. And what the script is going to do is it's going to count how many enemies are still in the scene. And if that reaches 0, we'll load the next level. First of all, we have to detect if the amount of enemies reaches 0. And the easiest way to do this is A, by clicking on this enemy, this Phoenix Fox, and we have to give it something to identify it by. We could check for its name, but as you can see, it's going to suffix it with a number. And there's a better way to check that a node is an enemy or a Phoenix Fox or specific node, which is a group. So let's create a group. Let's call it enemy. And this Phoenix Fox is part of this group. So as you can see, Phoenix Fox is part of group enemy now in all of the instances of it because we changed it in the root scene. So all of the instances are now going to have the enemy group. So in the level function, in this level, what we want to do is we want to loop through all of his children and count how many of his children are in the enemy group. So the way we do this is for child in get children, if child dot is underscore in underscore group, we'll say enemy, num enemies plus num enemies plus equals 1. And let's create a number bar. Num enemies integer 0. So basically, we're looping through its children. If one is a enemy, we increase the number of enemies. So now we have a representation of how many enemies are in the scene, but we don't do anything when these enemies get destroyed. So how do we detect that the enemy gets destroyed? Well, we can click level 1 and under node and back to signals, we see we have this signal called child exiting tree, which basically means if a child of this node is being destroyed, it's going to call this signal and tell us which child is being destroyed. So what we can do is just check if the child that is being destroyed is in the group a enemy, then the number of enemies decreases by 1. So at the very start, we count the number of enemies, and every time a child of this node gets destroyed, we decrease the number of enemies. Then we check. If the number of enemies is smaller or equal to 0, Q3, so the level is just going to destroy itself. Let's test it. So basically, we can just put back, shoot, and let's destroy the one enemy and wait for our bed to stop rolling and destroy our second enemy. And now the entire level is gone. So we wanted to automatically start the next level. The way we're going to do this is using a signal. So we've worked with signals here on the right, where we connect a signal to a node, where we connect a signal to a function on the script, but we have not created our own signal. But basically, this level is going to have a signal called 1, and when the level is finished, we emit this signal. Now, any other node can subscribe to the signal. Speaking of subscribe, anyways, speaking of subscribe, please subscribe. Okay, anyways, now we have a signal 1 that gets emitted when we win the level. We want our game to subscribe to the signal, so we go new level .1.connect, and we can connect the signal to a function. So let's get a function level 1, and now we do this. So we're connecting the one signal on our level to this function, and when this gets emitted, we call this function, and basically this function will just load the next level. For example, the second level. Let's quickly create a level counter. So level counter int is equal to 1. We load level counter, and when we win a level, we increase the level counter by 1 and then load this level. Basically, we load level 1. When we win it, we increase the level counter to 2, and then we load level 2. When we win it, 3, and so on. So let's test it. Level 1. I just won level 1. level 2. I just want level 2. And if I'm not mistaken, yeah, all of this works. Now, you've seen one problem, which is once I beat a level, my bed just stays there. So we want to reset the bed. The easiest way to reset the bed is having a signal called reset bed. And basically, when we load a level, we want to emit the signal, and we want the bed to subscribe to the signal. So get parent, basically the bed is here, its parent is this, dot reset bed, we connect to kill. And this is not in the right location. It should be under start. So on the very start, we connect the signal to kill. So when the game says reset bed, we will destroy the bed. Great. Let's see. And that's working. Let's test it again. Boom. Yeah. And the bed is resetting, and we can shoot. And let's create one more level just so you know the process. It's going to be adding a node, calling it level 3, then adding some things into the level, adding some more things into the level. Maybe moving this, putting this on top of these two, and then the third one like this. And then we just take all of these nodes, child it to level 3. We give level 3 the level script. We save level 3, and basically this will, oh my soul, I forgot to, when you save it as a scene, delete it afterwards to have an empty scene with no level. So now when we press play, it loads level 1, and we failed level 1 immediately. Let's try that again. Oh my word. 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 Okay, we got level 1 done. Level 2 in one round, and there we have a problem. It seems to not be wanting to load level 3. And this is actually because, as you can see, in level 1, we connect the child exiting tree, but in level 2, we don't. And in level 3, we don't connect child exiting tree. And we could go through and connect it in every single level, but instead, let's disconnect this and instead connect it with this script. Since all of the levels already have the script, we can just connect it on all the levels. And basically, like you connect any other signal, child exiting 3 dot connect to underscore on child exiting 3. Yeah. So if we run it now, we can beat the level. Oh. If we run it now, we can beat the level, and this level as well. And we beat the third level, and we get an error. This is because we're trying to load the fourth level after we've won the third level. The only problem is there is no fourth level, so it's going to give an error because it's trying to load something that doesn't exist. Okay, so the way we're going to do this is just add a constant called max level that is equal to 3. Basically, if the level count is bigger than max level, is smaller or equal to max level, load the level. Otherwise, we're just not going to do anything. Boom. And first try. and first try. There. So we've won the game and we've loaded all the levels. And that is Angry Bird. Now, I challenge you to add some polish, maybe add a trail, add some particles, add some sounds, all of that. And then you have a nice bird game. Even maybe add randomized bird colors, have a function that takes this bird and gives it a random modulate like blue every single time it spawns. You could figure that out. Just ask chat if you get stuck. Chat knows everything. Boom, you got it. Thank you. Subscribe, like, notifications, subscribe again. Tell your friends. Okay, bye.